Welcome to the full end-to-end Solana blockchain and smart contract bootcamp. We're going to go through everything you need to know from a technical standpoint to get started building on the Solana blockchain and write your own full stack decentralized applications. Whether or not you have been in the cryptocurrency space for a while or are just getting started, we'll be taking you through your journey to learn how to become an expert Solana engineer. At the time of recording, Solana developers are in high demand. We're seeing a ton of jobs getting posted within the Solana ecosystem. Over the last 3 years, Solana developers participating in global hackathons have created companies that have received over $600 million in funding. And on average, blockchain developers right now are making more than $170,000 a year. While we cannot guarantee you a job, we're going to try our best to provide you with the skills you need to become a Solana developer. Whether or not you have any blockchain experience or have been building for a while, if you are interested in building in blockchain, this is the course for you. We'll be starting with blockchain basics, then going into full end-to-end projects, and finally finishing up with what it takes to get your new application to production. If you have already built some smart contracts or are familiar with blockchain, feel free to jump around the bootcamp to find which projects best fit your needs. You'll be able to find all the information you need to know about each project in the description, as well as in the GitHub repository linked below. You'll find the entire bootcamp in this GitHub repository, including any possible resources you may need, such as links to documentation or further reading on topics. Throughout this bootcamp, we'll be learning how to build on a blockchain and be using both Rust and TypeScript to accomplish this. Don't worry if you don't know these languages, as we'll be teaching you enough to get started throughout each lesson. As long as you have some software development background, you should do well. Even the best developers don't get it right the first time. If you do happen to run into issues at any point in this bootcamp, there's a Solana-specific Stack Exchange where you can get help. The Solana Foundation Developer Relations team and other developers from the ecosystem will be answering your questions there. Just make sure you search for your question first and provide enough information about your error you received while building each project. We will also post the full solution at the end of each step and in the notes below. It is incredibly important that you pace yourself while going through this bootcamp. This is a marathon, not a sprint. Take breaks so you can have some time to digest what you've just learned. Go back to different projects as a refresher. Take the course at your own pace. My name is Jacob Creech, and I'll be working with you on some of these projects throughout this bootcamp.
I'm Brianna Migliaccio, and I'll be leading you through how to build smart contracts and decentralized applications.
And I'm Mike McKenna. I'll be working with you throughout the bootcamp on key blockchain concepts. Before you start building, you should understand the purpose of blockchains and the problems that they solve. Fully understanding the value blockchain provides will help you leverage it to solve the right problems. So let's get started. So what is blockchain? Why is it important? And what can you do with it? At its core, a blockchain is a distributed database with some special characteristics. Unlike most databases, blockchains are unique in that they have no central authority, are fully open for anyone to use, and all data is completely transparent. Everyone can make payments on the blockchain, while no one entity is capable of stopping or reversing those payments. This is what we call censorship resistant. The transactions are irreversible, and the blockchain itself is a recording of those transactions. That's why blockchains are often referred to as a ledger. Unlike databases, which are typically stored in a central location, data on blockchains are stored on multiple computers across the world. Essentially, there's no single copy of the blockchain that can be lost or tampered with. Instead, the data is stored in multiple copies and verified by checking the blocks or bundles of transactions. This is called decentralization. What this means in practice is that blockchain allows people to transact with each other directly. Think about the last time you paid for something, or swapped currencies, or just stored your money somewhere. You might have used a credit card, or a money transfer service, or a bank. To facilitate that, there's typically a service fee involved. The seller pays a couple of % on every credit card transaction. You pay a little bit more for an international transfer. And your bank probably has a monthly fee just to hold your money. Blockchain allows people to transact with each other directly without needing somebody in between. Now, to understand blockchain, you need to start with Bitcoin. Back in 2008, Bitcoin was created by the pseudonym Satoshi Nakamoto as a way to make digital peer-to-peer payments. The white paper for Bitcoin outlined a way to make those payments without having a trusted third party, such as a bank or other financial institution. Blockchain uses digital signatures to let people transact without having to fully trust each other. Digital signatures give us confidence that the money sent is in the correct currency, that the amount is correct, and the amount was actually sent. Bitcoin was created more than 16 years ago, and these days it's less used for day-to-day transactions. People think of it more as digital gold. However, plenty of new innovations have been built since then. Modern blockchains, like the one that we'll be building on, Solana, support fast payments with lower fees than both Bitcoin and traditional finance. Not only that, but new creations, like smart contracts, have enabled a whole new set of capabilities previously not available to blockchains. Smart contracts are computer programs that run on a blockchain. Instead of having a cloud provider run your program, you run the program in the blockchain. Smart contracts are a little bit like APIs in the traditional tech world, except rather than being invoked by requests, they're invoked by instructions. And rather than sending responses back, they write their changes out to the blockchain, where anyone can read. Smart contracts extend blockchains beyond simple payments to allow complex transactions that could lend money without a bank, allow people to exchange items directly with each other at a price they both agree on, or even create a lottery without a lottery ticket issuer. We're going to build these in this bootcamp, so you can see how powerful smart contracts can be for yourself. Blockchain would not be possible without cryptography. Everyone that uses a blockchain has something called a key pair. A key pair consists of two keys, a private key and a public key. The public key is shown to anyone. It's used as an address people can use to transact with you. The private key you must keep secret. The private key is used to sign transactions, which proves that you made them. For example, want to spend some of your tokens? You'll need to sign the transaction using your private key. Anyone else can use your public key to verify that you, as the holder of the matching private key, made that transaction. Key pairs are pretty common in cryptography, even outside blockchain. Let's use the example of passports. Your electronic passport is signed by your government, using your government's private key. When you pass through the passport gates at the airport, they use your government's public key to prove your passport was really signed by your government. If the passport signature is correct, it must have been signed with your government's private key. If I make my own passport, it won't be signed by my government's private key, so I won't be able to get through the gates. In Solana, everyone has a public key they use as their address. Other people can use your address to transact with you. The most basic Solana wallet is just an address with a small balance of Sol. Users can pay their transaction fees and interact with smart contracts using Sol. Here's Alice's wallet. Here's Bob's wallet. If Alice wanted to send Bob some Sol, she would use her private key to sign a transaction that uses the system program's transfer function to send some Sol to Bob, and uses the memo program's memo function to write a little note to Bob about the transaction. If both these steps, called instructions, are completed successfully, the transaction completes successfully, and Bob receives the tokens in his address. If something goes wrong, that's okay. The transaction fails and nothing changes. Alice will still have her Sol. Blockchain technology allows for new applications to be built in this digital age. We can create systems where people transact with each other directly, make digital assets that can be sold or used outside of a game, allow art to be sold, and ensure artists get paid each time a piece of artwork is transferred. The projects we'll be building throughout this course will use the Solana blockchain to create unique applications that can only be built with smart contracts. Let's get started with your first application. The first smart contract we make will be simple. It's going to save our favorite things to the blockchain. We're going to learn how we can save, update, and retrieve information from the blockchain, and how signing is used to control access in our smart contract. In the previous lesson, we learned how everyone has a key pair, a public key that can be used as an address to transact with that person, and a private key that they use to sign transactions. In Solana, your smart contracts, or programs, can store additional data in what's called program-derived addresses. PDA addresses are not made from a public key. Instead, they're made from seeds, which can be whatever you, the programmer, want. Want to store some config for your smart contract? You can make a PDA from the seed config as a string. When you need to find your program config, look for the PDA made from that seed and you'll find your config. Want to store Alice's review of the movie Titanic? You can combine Alice's wallet address and the string Titanic to store the movie review. Need to store Bob's review of the same film? You can combine Bob's wallet address and the string Titanic to store his review. If you've used a key value store before, you might be thinking this is familiar, and yes, Solana PDAs are a type of key value store. If you haven't used a key value store before, you can think of a PDA as a row of data, with the seeds being the primary key used to find the data. So, let's build a simple app that saves someone's favorite things to the blockchain, and uses digital signatures to ensure only the wallet holder can update their own favorites. We'll use Solana Playground and Anchor, the most popular framework for making Solana programs.